Okay, now we're going to continue with this. Okay, uh, let's look for another equation. Okay, quadratic function. Let's say we look at another function y, or let's say y equal to x squared plus 2x plus 1. Okay, now let's do the checking. B squared minus 4ac. Okay, b squared, b is actually 2, so b is 2 squared minus 4. A is here is 1. Okay, c is actually 1. Now, so 4 minus 4, which gives you equal to 0. If equal to 0 means I know this quadratic function, the minimum point of this quadratic function will touch the x-axis. Okay, there is one point of intersection. So in other words, the x-axis is actually a tangent to the curve at the lowest point. Okay. Okay, let's consider another function. Y equal to x squared plus 2x, let's say plus 4. Okay, now let's do this checking again. B squared minus 4ac. B squared in this case is 4 minus 4. A is 1. C is 4. Okay, so 4 minus 16, which gives you minus 12. This is less than 0. Okay, so by doing this analysis, I know this function, if I plot it, the minimum point will not, this function will not intersect with the x-axis. In other words, there is no x-intercept for this quadratic function. If I put y equal to 0, I will not be able to obtain x1 and x2 value. Okay. In this case, if I put y equal to 0, I want to find the x-intercept. I will realize that the x1 is actually equal to the x2. There are two equal x-intercept. Okay, the x1 and x2, when y equal to 0, the x1 and x2 will be exactly the same. They are called equal root. Okay, equal x-intercept, because there is only one point of intersection or contact. Okay, now in this case, when I put y equal to 0, this, like what I did here, I noticed there's two different x value. The x1 and x2, they are different. So in other words, there's two solutions to the quadratic equation when y equal to 0. When y equal to 0, which is the x-axis, there's 2 points of intersection. You have two, x1 and x2, like this case here. Okay. Now, let's look at this. If b squared is less than 4ac, b squared minus 4ac is less than 0, like this case here. Okay. There's no intersection. That means you cannot find the x1 and x2. value. The proper way of saying is we have no real root, no x-intercept, then y equal to 0. Okay. We only have a complex root. Okay. Now, when you have b squared minus 4ac bigger than 0 equal to 0, the equation have real roots. Okay. The difference is if you take b squared minus 4ac equal to 0, okay, equal to 0, which is this case here, okay, equal to 0, then the equal have equal roots. That means the x1 and x2 are the same. They are equal. Okay? This one you come to it. Okay? This one when you do differentiation. Now we are not looking at this section. Now, take the case when it's bigger, b squared minus 4ac bigger than 0. You notice that the roots are unequal, but they are distinct. Distinct means they are real root. Okay, they are not complex root. Complex root means this one teacher will come to you later. Okay, so they are unequal. For example, here minus 3 and 1. They are two different roots. Okay, now this one we will come to it later. So in this video, basically teacher is trying to teach you how to recognize a quadratic function, whether it will intersect with the x-axis or not. Okay, or there's 2 point, 1 point, or no intersection. In other words, another way of looking at it is when you put y equal to 0, okay, when you put y equal to 0 and you form a quadratic equation, you want to know is there any root or not. In like this case here, is there x1 and x2 value? Okay, you're able to predict, okay, without actually work out the x1 and x2. You're able to predict there is 2 root to the equation, okay, by looking at the magnitude of b squared minus 4ac. You're able to predict is there any root. Root basically you are talking about the x-intercept in this case when y equal to 0.